In this slide, we're focusing on data validation for secure coding. The purpose of data validation is to ensure the integrity and security of the data that your application processes. By validating data, we prevent malicious input from affecting the application. This step is crucial in avoiding vulnerabilities that could be exploited by attackers to compromise the system. Proper data validation acts as a first line of defense, ensuring that only correctly formatted and appropriate types of data are allowed to interact with the system, thus maintaining both security and reliability. The importance of data validation cannot be overstated. Data validation plays a crucial role in mitigating security risks such as SQL injection, cross-site scripting, XSS, and buffer overflow. By ensuring that the data conforms to the expected format and type, we not only protect the application from malicious input, but also enhance the overall reliability and user experience. Robust data validation mechanisms are essential for preventing unauthorized access and maintaining the integrity of the data that flows through our applications. Moving forward, let's focus on the practice of data validation on trusted systems. This principle emphasizes the necessity of conducting all data validation on a trusted system, typically the server. While client-side validation is valuable for enhancing user experience by providing immediate feedback and filtering out obvious errors, it should not be relied upon as the sole mechanism for ensuring data integrity and security. The reason is straightforward. Client-side validation can be easily bypassed. Users with malicious intent can disable JavaScript or manipulate the data directly, thus circumventing the client-side checks. By ensuring that all crucial data validation occurs on the server, you mitigate the risks of security vulnerabilities like SQL injection, cross-site scripting, XSS, and buffer overflow. This approach guarantees that the data conforms to the expected format and type, enhancing both application reliability and user experience. When addressing character encoding and canonicalization, it's crucial to canonicalize input by encoding data to a consistent character set before performing any validation. This ensures that the data is represented in a standard form. For instance, in Java, you can canonicalize input using the java.text.normalizer class. Java string canonicalized input equals java.text.normalizer.normalize input java.text.normalizer form.nfc. According to OWASP, canonicalization is key to ensuring your validation logic is effective across different encodings. This step is essential as it avoids issues that arise from data being represented in various formats, which can lead to validation bypasses or inconsistencies. By standardizing the data through canonicalization, you create a reliable baseline for your validation processes, thereby enhancing the security and robustness of your application. UTF-8 handling is crucial for properly managing and validating user input in web applications. When dealing with systems that support UTF-8 encoding, it's important to perform validation after the UTF-8 decoding process is completed. Consider the following example in JavaScript to decode UTF-8 encoded data. JavaScript let UTF-8 decoded data equals decode URA component escape input. Perform validation on UTF-8 decoded data. Here, decode URA component is used after escaping the input, ensuring that the data is correctly interpreted in its original form before applying validation rules. This step is necessary to avoid mismatches or errors during the validation phase, as encoded data might not comply with your validation logic directly. UTF-8 decoding plays a critical role in handling character data comprehensively and preventing potential security issues, ensuring integrity across different encodings and inputs. When discussing validating client-provided data, it's crucial to recognize the different areas that require validation. These areas include form fields, URLs, and HTTP headers, such as cookie names and values. Each of these components can be manipulated if not properly validated. Imagine a scenario involving auto postbacks from JavaScript. In the example provided on the slide, we have a simple function safe_postback. JavaScript function safe_postback let input equals document get element by ID user input to value. Apply validation rules here before sending post to server input. Here, user input is retrieved from a form field. Before sending this data to the server must ensure appropriate validation rules are applied to protect against potential security risks, such as injection attacks or data corruption. This validation process helps maintain the integrity and security of the system by ensuring that only properly formatted and safe data is processed and stored. In this slide, we will discuss the concept of trust boundaries. First, it's essential to identify and comprehend all system trust boundaries. These are the points where data enters or exits your system. By determining these boundaries, you can ensure that all data crossing these points is meticulously validated. This can include interactions with databases, file streams, or any external data sources. A practical tip is to understand which components of your system interact with external data sources. This knowledge allows you to implement rigorous validation procedures, ensuring that untrusted data is properly vetted before being processed further. This approach helps maintain the integrity and security of your system by preventing potential vulnerabilities associated with unvalidated input. In this slide, we're focusing on the critical concept of encoding data to ensure secure communication and storage. Specifically, we're discussing the implementation of a master encoding routine. This routine should be utilized in a unified approach for both inbound and outbound data encoding. A master encoding routine ensures that all data is handled consistently, reducing the risk of vulnerabilities such as injection attacks. The example provided here demonstrates how to encode data for HTML in Python. By using the html.escape function from the HTML library, we can ensure that any special characters in the input data are properly escaped, thereby preventing potential HTML injection. Let's take a closer look at the provided example. Python import HTML, def encode for HTML data, return html.escape data. This function, encode for HTML, accepts a single parameter data and returns the encoded version of that data. The html.escape method replaces special characters like n and n with their corresponding HTML entity codes, making the data safe for HTML contexts. By implementing a master encoding routine like this, you're proactively protecting your system from a range of injection attacks, ensuring that both incoming and outgoing data are properly encoded. This helps maintain the integrity and security of your application, especially when dealing with external data sources. Next, we'll delve into input validation using a whitelist approach. When validating input in your applications, it's crucial to differentiate between using a whitelist versus a blacklist approach. On this slide, we are focusing on the benefits of a whitelist. A whitelist defines an allowed list of characters that are considered safe. Using this method ensures that only the specified characters are accepted, reducing the risk of unexpected inputs causing security vulnerabilities. Here, we have an example in Java to demonstrate this concept. The isValidInput function checks if the input string matches a regular expression comprising only alphanumeric characters and underscores. Java public boolean isValidInput string input. Return input.matches AZZ$9. This ensures that any input not matching these allowed characters will be rejected. Now, consider the limitations of using a blacklist approach. A blacklist specifies characters or patterns that are not allowed. This might initially seem sufficient, but it fails to cover all potential malicious inputs comprehensively. Attackers can often find creative ways to bypass blacklists by using unexpected characters or sequences, which ultimately makes blacklists less effective in comparison to whitelists. Understanding these differences is vital for developing secure applications. Up next, we will discuss how to sanitize hazardous characters to further enhance input safety. On this slide, we focus on sanitizing hazardous characters to prevent security vulnerabilities, such as cross-site scripting, XSS, and SQL injection attacks. It's crucial to handle characters like sent and sent, and plus carefully, as these can be exploited by attackers. For instance, in JavaScript, you could sanitize an input by using a regular expression to remove these characters. Here's an example function. JavaScript function sanitize input, return input.replace/g. This method ensures that any malicious input is stripped of potentially dangerous characters, securing your application against various attack vectors. Always remember, effective input sanitization is a fundamental aspect of maintaining secure software applications. Validating your data is an essential step for ensuring the integrity and security of your application. On this slide, we'll focus on how to validate data types, ranges, and lengths. Firstly, it's crucial to validate the expected data types. This means verifying that the data received matches the types that are expected in your application. For instance, an age field should be an integer. Secondly, always ensure that the data falls within acceptable ranges and lengths. Let's look at the example provided in this slide. In the JavaScript code snippet, the function validateAge checks if the input is an integer and falls between 0 and 120. This way, we make sure the age is within a realistic range. If both conditions are met, the function returns true. Otherwise, it returns false. By enforcing these validation rules, you help protect your application from potential errors and vulnerabilities, ensuring that the input data is not only correctly formatted, but also within expected boundaries. This forms a solid foundation for securing your application's data. When dealing with output in your applications, protecting client data through contextual encoding is critical. contextual encoding ensures that data returned to the client is properly encoded to prevent injection attacks, particularly when handling HTML content. For instance, in Java, you can use the Apache Commons text library to safely escape HTML characters. The example method provided, escape_HTML, takes an input string and encodes it using string_escape_utils.escape_html4. This ensures that special HTML characters are converted to their corresponding HTML entities, effectively neutralizing any potentially malicious code embedded in the input. Java import org.apache.commons.text.string_escape_utils, string_escape_HTML string input, return string_escape_utils.escape_html4 input. Using methods like this is a best practice to secure user-provided data before displaying it in a web interface, thereby protecting your application and your users from various forms of injection attacks. When handling special cases in input data, it's essential to perform additional checks to ensure that your application remains secure. In this slide, we focus on specific characters and sequences that can potentially introduce vulnerabilities if not properly managed. Null bytes, new line characters, and directory traversal sequences, like .. For example, in Python, you can create a function check special cases to validate the input. Python def check special cases input if x00 in input, or n in input, or / in input, return false, return true. This function checks for the presence of null bytes, new line characters, or R, and sequences that could lead to directory traversal attacks like /. If any of these are found in the input, the function returns false, indicating potentially unsafe input. Otherwise, it returns true. Integrating these additional checks helps in safeguarding your application against a broader set of input-based attacks, ensuring better overall security. To prevent double encoding and obfuscation attacks, it's crucial to implement canonicalization in your validation processes. Obfuscation can disguise malicious input by encoding it multiple times, making it harder to detect. Canonicalization involves decoding the input until it reaches its simplest or most standard form. Let's look at an example of how this can be done in JavaScript. In this function, canonicalize, we decode the input twice to ensure that any potential double encoding is addressed. JavaScript function canonicalize input, return decode URA component input. By decoding the input consecutively, we convert any obfuscated encoded data back to its original form. This way, your validation logic can accurately assess the input and catch any malicious attempts that might have been hidden through obfuscation. In summary, here are the key points to remember. First, always ensure that all input is validated on a trusted system. Server-side validation is generally preferred to maintain the integrity and security of your application. Second, before you perform validation, canonicalize the data. This ensures that any double encoding or obfuscation tactics are addressed, providing a clear and normalized input for validation checks. Third, make sure to validate data coming from all external sources. This includes user inputs, third-party APIs, or any external system interactions. Finally, use context-aware encoding for all output. This means applying the appropriate encoding based on where the data is being rendered, such as HTML, JavaScript, or SQL contexts. Implementing these practices helps secure your application against a range of common attack vectors. Now that we've covered the key points about secure coding practices, here are some valuable references that can further enhance your knowledge. Firstly, I highly recommend the OWASP Secure Coding Practices Checklist. This checklist is a comprehensive resource that outlines essential secure coding practices to help you reduce vulnerabilities in your software. For those looking to deepen their understanding, especially in specific programming languages, there are two excellent books. Secure Coding in C and C++ by Robert C. Secord dives into secure coding techniques specifically for C and C++. It's a must-read if you work with these languages. Additionally, JavaScript: The Good Part by Douglas Crockford is a fantastic resource that focuses on writing cleaner and more secure JavaScript code. Both these books and resources will provide you with the practical knowledge needed to apply secure coding principles effectively in your projects. Make use of these references to ensure your code is robust and secure. Thank you. I hope you enjoyed the content presented in this course. If you did, please leave a like and comment below to let me know your thoughts. Don't forget to subscribe to the channel for more informative videos and share this course with friends and colleagues who might benefit from it. Your engagement and feedback are greatly appreciated.